All right, what's up, guys? Today I'm going to be going over lesson 6.6. So I went from 6.4 and I skipped over 6.5 because I think 6.6 is a bit more important, relevant to the content that you'll be tested on. So it's called solving cube root equations. Whenever we think of the word solving, I like to think of what we're trying to solve for. What's the point of what we're trying to do? And we are trying to solve for x. Usually in algebra, we're trying to solve for x, trying to find x. What is x? And the only difference is that the context is going to be cube root equations. We're going to have an equation that's going to look something like this, the little cube root, and we're going to find x. So as a reminder, we have inverses. The inverse of the cube root is going to be x cubed, and vice versa. The inverse of the cube is going to be cube root. And finally, remember that in lesson 6.1, we said that we can rewrite radicals as a fraction. So hopefully if you remember, we would get that little number on the outside and we would put it as the denominator, which is what we have here. But anyways, let's check out example 1. These things are much better learned with examples, so let's check it out. So step 1 is to isolate the radical, meaning this radical right here needs to be left by itself. And the way that we're going to do that is we have to see other things around it, such as this 4 and this -5, and we have to move them over. So the first thing I'm going to do is add 5 to both sides. The reason I do that is so that the 5s could cancel out, and all I'm left with is 4 cube root of 2x minus 1 equals 8. Now that I have that, I see that 4 times all that stuff. So the opposite of 4 times that is to divide by 4, giving me cube root of 2x minus 1, since the 4 is canceled out, is equal to 2. From this point on, we have finished step 1. We have the radical isolated by itself. So step 2 is to cube both sides. So cubing refers to raising it to the third power as such. And if you do it to one side, you do it to the other side. So I'm drawing a little arrow. But whenever we cube things, notice that that 3 is going to cancel out with the cube root inside, meaning all that we're left with now is 2x minus 1 equals 2 cubed. So 2 cubed is basically like 2 times 2 times 2, which the first 2 times 2 will be 4, times another 2 is going to be 8. The last steps is just to solve for x like a normal equation. So all we got to do is add the 1 to this side. We end up with 2x, cancels out, is equal to 9. And finally divide by 2. So our answer should be x equals 9 divided by 2. So that looks pretty good. I'm very pleased with that answer. And I just want to put you guys in this scenario. Let's say you're doing a question like this on a test, and you find an answer that you're not 100% sure it's right. So these are going to be 2 solutions, or 2 methods for you to check your solutions. So method 1 involves substituting your solution in place of the variable. So that means that we are going to place this 9/2 inside of the equation wherever we see an x, which means we're going to end up with something such as this. Parentheses, 9 divided by 2. And the solution, or the reason this is going to check our solution, is we're going to see if there is equality. If that indeed is the answer, then we should see that the equation is satisfied. So all we're going to do is work out all this arithmetic. So I see this little thing, 2 times 9/2, so the 2's cancel out. So we just end up with 4 cubed 9 minus 1 minus 5 equals 3. I also see this, 9 minus 1 is going to be 8 minus 5 equals 3. And now we have this question. What is the cube root of 8? What number multiplied by itself 3 times will give us 8? And the answer to that is going to be 2. So last mental math thing that we want to do, we got this 4 times 2 here, and that's going to be 8. And finally, we got that 8 minus 5, which is going to be 3. And that is equal to 3, which is right. This is a true statement, so that means our answer must be correct. Sounds perfect. But let's say you don't like doing all this. Let's say you're given a graph during the test, a graphing calculator, which it might be like a Desmos graphing calculator, like how you're always given. But anyways, let's say that we are able to separate this into two graphs like this. This one right here and this one right here, which is exactly what we have right here. This is the first one, this is the second one. If we are able to graph this, then we'll see the intersection point. And that intersection point will tell us if we have a correct solution or not, which ideally should be at 9/2. So if we were to graph it on the Desmos calculator like I have done over here, then you'll see we get these two shapes. The red one is the cube root function right here. The blue one is just 3. So let me draw those shapes. And I see it intersects there, 4.5, 3. So let's just see how. This is going to be a rough sketch. It doesn't have to be extremely perfect. Something like that. And we got a straight line at 3. So we have an intersection at around this point, 4.5, 3. And this should be good news. We have an x value of 4.5, which doesn't look like the answer, but it could be rewritten as 9/2. Meaning this is the answer because the intersection point is the same as the x that we found. It is the answer. 9/2 is equal to 4.5. We're going to continue with these types of problems. Hopefully we kind of understand what the point of this is. We're trying to solve for x, and we got to manipulate the equation so that we can have x by itself. So I see this equation, and I always just want to isolate the radical. So if I subtract 7 on both sides, I'm going to end up with 7 times cube root of 3, 2x plus 5 is equal to 14. Next step, 7 times all that, so I want to divide by 7. It's going to cancel that out. So now we got cube root of 2x plus 5 is equal to 14 divided by 7, which is 2. Next thing, we have cube root of all that. So now that we isolated, we want to cube both sides. So that's going to cancel out here. So we got 2x plus 5 is equal to 2 cubed, which is 8. Next thing, we are just going to solve this like a normal equation now. So we're going to start by subtracting 5 on both sides. That means we're going to end up with a 2x equals 3. Finally, we just got to divide by 2 on both sides, giving us x equals 3 divided by 2. Perfect. Simple as that. Just step by step doing the inverse operations. If we want it isolated, we got to add or subtract or divide or multiply depending on what's going on. Let's look at this one. And this one looks completely different than the other ones, but let me give you a hint. It's actually not completely different at all. So 3x minus 1 to the power of 1/3 is exactly the same as writing it as a cube root. It is exactly the same. We did a lesson. I mentioned lesson 6.1 in this video, where if you move that thing as the denominator, then you could rewrite it as an equivalent radical or equivalent exponent. But anyways, we got that. So we're going to cube both sides because it's already isolated. So doing that, we're going to get 3x minus 1, and that cancels out. We got 8 to the power of 3. So I wonder what that is. That's going to be 8 times 8 times 8. That is equal to, well, these first two are 64 times 8. And this is going to be 60 times 8 is 480 plus 32 is 512. You can use a calculator if you don't know how to do big multiplications like that. But it just takes a little bit of practice. I encourage you to just try it out. Now that we have this, we're just solving for x. Add 1 to both sides. End up with 3x equals 513. We get x is equal to, if we were to divide this by 3, 171. I know I'm going kind of fast, but you can always feel free to pause these videos at any point. All right, next question. So we have something like this, and this is kind of complicated because we got radicals on both sides. But the trick is to cube both sides anyways. So we're going to cube this side because it's isolated. But if we cube the other side, then it also cancels out the cube root. So the main idea is that the cube root is canceled out on both sides. And now from here, we just solve this like a normal equation. We got the minus 2x to move it over here to the other side. And then in the same turn, I'm going to subtract the 5 as well. So if we add up everything, we get the minus 6 from here. And then we also end up with 3x from this. From here, the last step is just to divide by 3, giving us x equals -2. Next question, we got this one. And this one looks even weirder. We got like a fraction, but it really isn't too bad. I'll show you guys a trick. Whenever you have something down here as the denominator of a fraction and just a number out here, you can always swap the places of this. Meaning we have an expression of 1/3 is equal to cube root of x. And now that we have this, we can just cube both sides. So this is going to cancel out with that. Now we have this one, which is going to be 1/3 cubed is equal to x. And the way that this is rewritten is each one of those numbers is cubed. So that cube at the top right here gets distributed to each one of those terms, giving us 1 times 1 times 1, which is 1. 3 times 3 times 3 is going to be 27. So this is going to be our answer. Last example. We have something that looks kind of similar. We have a fraction, and we have a number out here. So we're going to do that same thing. We're just going to swap these things completely. So we have 2/5 is going to equal to cube root 3x plus 1. And the first step is just to subtract the 1 out here on the outside. So we're going to end up with 2/5 minus 1 is equal to cube root 3x. Because that canceled out the 1 at the end. So this actually is going to be something. This is going to be, if I write it in red over here, we got 2/5 minus 5 divided by 5. Go back to 5th grade fractions. So that means in total we have -3/5 is equal to cube root 3x. From this point, the radical is isolated, meaning we want to cube both sides. It's going to cancel out that. So we're going to end up with a 3x is equal to -3 cubed divided by 5 cubed. The last step is to divide by 3. So when you divide by 3, you could just divide it and put it at the bottom like that. So x is going to be equal to -3 times -3 times -3 divided by 5 times 5 times 5 times 3. So the reason I wrote it like this is so that we could see that one of the 3's cancels out and we're left with a -1 up there. So our answer should be -3 times -3 times -1. That should be a -9. Then the 5 times 5 times 5 is 125. So honestly, these examples are the hardest ones. On the homework, it should not be that bad, and it'll be adjusted based on, the type of problems I want you to know how to solve. But that is basically the gist, just solving for x and using these algebraic manipulations. Hopefully this video